All right, welcome back, Algebra. You should have just finished a sort of exploration activity where you're looking at how different parts of a function uh, change the quadratic depending on where different numbers located in the equation. Um, so essentially, we are learning about something called vertex form. So quadratics have a special way that they can be written in vertex form, which makes them very easy to graph. And the vertex form of a quadratic is written as y equals a quantity x minus h squared plus k. And each of those three letters, a, h, and k, have a unique feature that you probably noticed in your little exploration activity. But I'm going to click on this link and we're going to talk a little bit about more specifically what each of them do. So pulling up Desmos here, let me make this a little projector mode so it's a little bit easier to see. So starting off with our function, so once again, we have these three letters, A, H, and K, and they're each going to change the function in a different way. If we change A, if I have this, move the slider, if I move it, we can see that my function is getting wider and skinnier as I move it, and it even flips down below and does the same thing at the bottom. So it's wider or skinnier at the bottom, down there, and up at the top. It's hard to get it to get pretty wide on here. But A is going to change that width of your function. It's going to change the wideness or the rate at which it increases upward of your function. So that A value in front of the parentheses is always going to be that. If it's a positive number, we're above. If it's a negative number, we're going below. So we're going down if it's negative. If it's positive, we're going up. One way to remember that is if it's positive, you're smiley, you're happy. If it's negative, you're frowny, you're upset. So you can think of like upside down, frown, and all that fun stuff. All right, now we'll move on to K. So H. H is the number that's inside your parentheses next to the X. It's always minus H. So if I have like H as 5, looking at the points on my graph, I can see that the vertex of my function, the vertex meaning that central point of your function, that turning point, the vertex, the x coordinate is 5. If I move h to -7, I can see my vertex is, if I can click on it, -7. So moving this number moves our function left and right. Now, the thing is that we need to remember, though, is it's minus k, or it's minus h. So even though I might have 5 or 6 as my h, it's going to be written as -6 in my actual function. So it's going to be x minus 6. So it's always going to be sort of opposite of what you think. So if it's negative, I'm going to the right. If it's positive, I'm going to the left. And then lastly, we have k. K is going to move our function up and down. So if I have a k of 3, if I can get it there, that's pretty much close enough. If I have a k of 3, I can see the y coordinate of my vertex is going to be 3. If I have a k of -7.4, I can see my y coordinate. Oh, that's a bad number because it's way too low. I can see my y coordinate is going to be -1.1. It's always going to match that k. So the h is going to match your x coordinate of your vertex. The k is going to match the y coordinate of your vertex. So the h is going to move you left and right. The k is going to move you up and down. And the a is going to change your width of your function. So getting back to this, if we know what these three things do, then we can easily graph the vertex. We can easily graph a function using this vertex form, as long as we know what is the a, what's the h, what's the k. And then we can find all of those key features that we had mentioned the other day easily using this. So let's look at this example here. So I have y equals -5 quantity x plus 4 squared. So the first thing I want to do in order to graph this is I want to figure out where is the vertex located on this function. Now I know it's always minus h, k is our vertex. Your vertex will always be -h, k. So I just need to think, using my numbers that I see showing up in my equation, what is -hk? Well, -h would be, my h is 4, so -h would be -4. What's my k? My k is -3, so -3. So my vertex should be located at -4, -3. So I'll go over 1, 2, 3, 4, 1, 2, 3, and that's going to be my vertex. Now, the next thing I need to determine, is my function going to open upward or is it going to open downward? Am I going to go up? Am I going to go down? And I can easily determine that looking at the a of my function. So the a of my function is -5. So -5 tells me I need to go down. It's a negative number. And I'm going to be going down rather rapidly because -5 is a number that's larger than 1. So I'm going to be a skinny function compared to a wide function. So typically, our normal parent function, our y equals x squared. If I go over one space, either to the left or the right of my vertex, I'm going to go up 1. If I go over 2 spaces to the left or my right of my vertex, I go up 4 because we always square the number. If I go over 3 spaces from the left or the right of my vertex, from my vertex, I'm going up 9. It's always that distance squared. Now, the thing is, if I were to use this pattern with my function, I need to take all of those values. I need to multiply them by my a, which my a in this function is -5. So 1 times -5 is -5. 4 times -5 becomes -20. 9 times -5 becomes -45. So essentially what's saying, if I go over one space from my vertex, either to my left or my right, my function is going down -5. If I go over 2 spaces from my vertex, my function goes down -20. If I go 3 spaces from my vertex, my function goes down -45. That's an easy way to graph this. Or, of course, you can always use Desmos. So if I'm going 1 to my left or 1 to my right, I go down 1, 2, 3, 4, 5. If I go 1 to my left, I go down 1, 2, 3, 4, 5. Similarly, if I were to go to over 2, if I were to go to 2 from my vertex, I would have to go down 20. If I were to go 3 from my vertex, I would have to go down 45. But this function is going to be very skinny. It's a very thin function. But that is going to be our graph. And now that we have this function graph, we can easily determine what are those other key features of our function. So what is the minimum or maximum of this function? Well, because our function is facing downward, because it's a negative quadratic, I know I'm going to have a maximum. The vertex is the highest spot of my function. So that the maximum of my function is going to be y equals -3. That's the highest value my function can reach, is -3. It's the maximum value. What is the axis of symmetry? Well, once again, we said the axis of symmetry is always going to pass through the center of our function. It's always going to pass through the vertex. So my axis of symmetry for this function is going to be x equals -4. Your maximum is always y equals your y coordinate of your vertex. Your axis of symmetry is always x equals your x coordinate of your vertex. Now, looking at our zeros. So where does our function cross 0 or the x-axis? Where does our function ever touch that? Well, I don't know. It's never going to touch it because our function is lower than the y-axis or lower than the x-axis, and it's always going down. There is no spot along this function that will ever cross 0 because our maximum of our function is -3. It's never going to intersect. So there are no zeros that are showing up. So just NA, not applicable. So there are no zeros that show up for this function because there's no x-intercept. The domain of our function, once again, all functions we talk about in Algebra 1 are always going to be all real numbers. That's an easy freebie point. And then the range. So once again, we are looking at the value of our function is always lower than that maximum. So we're every value below that maximum. So it's going to be y is less than or equal to because we do reach the maximum of -3. So we're always going to be below that value in this case because it's a maximum. We can't go above a max. And then the y-intercept of our function is a little bit harder because we can't see on this graph where we're crossing our y-axis. But if we think about it, our vertex is 1, 2, 3, 4 away from our x-axis. Our vertex is 4 away from our y-axis. I apologize. So if I were to go 4 over from my vertex, I know 4 squared is 16. So normally, on a normal quadratic function, I would be going up by 16 if I went over 4. Well, if I went over, but in this case, I need to multiply by a, which in that case is multiplied by -5. So 16 times -5 should give us -80. So that means from this value, if I were to go over 1, 2, 3, 4, I would then have to go -80 down from -3. So -3 minus 80 is going to give me -83. So my y-intercept should be at 0, negative 83. That's a terrible 83. Another way of checking this would be to plug, we know our y-intercept always occurs when x is 0. So another thing you could do is just plug 0 into this function. So you would have y equals negative 5 times 0 plus 4 squared minus 3. And you could just simplify that or plug that whole thing into the calculator right there. And that would tell you what y is equal to. It would tell you it should be 83 because we got 0 plus 4 is 4. 4 squared is 16. 16 times negative 5 is negative 80. Minus 3 is negative 83. So once again, same idea. We do the same thing. We just thought through the graph rather than through the function. And so those are all of our key features. Let's do one other of these before we move on. All right, so once again, we have another function right here. We have y equals 1/4 x minus 3 squared. Now, if we look, this function doesn't have a plus k. So if there's nothing written there, then we can have to assume that that function or that plus k is going to be 0 because it doesn't show up. But we do have an h. We do have an h of negative 3. So if we remember, our vertex of our function is always going to be negative hk. Well, negative hk is negative 3. Negative 3 is going to be positive 3. And then we said our k doesn't exist, so it's going to be 0. So our function is going to occur at 3, 0. So 1, 2, 3, up 0 is our function. Now, if we look at our function, our a of our function is 1/4. So this is a positive value. So I know my function is going to be going up because I'm positive, but I'm going to be wide because my a is a small number. It's less than 1. So I know my function is going to be a little wider. So normally if I think about my parent function, it goes over 1, up 1, over 2, up 4, over 3, up 9. But then we have to multiply by the a. So multiplying by the a, 1 times 1/4 is 1/4. 4 times 1/4 is 1. And then 9 times 1/4 is 9 over 4, which kind of simplifies down to 2.25. So using this information, we could easily get a little bit of a graph of our function. So if I go over 1, I go up 1/4, so just like a tiny little bit up. If I go over 2, I go up 1, because we should go up 4, but we're going over 1/4. And if I go over 3, I go up 2.25, so 2 1/4. So this is our wide function right here. Once again, you could graph more points if you wanted to go down through. If we went down 4, that'd be 16 times 1/4 would go us up 4. But I'm just going to stick with that for right now. So now that we have this function graphed, what is our maximum or minimum? So if we look, our function is going up. So we have a lowest part of our function. So the vertex is going to be the minimum in this case. Now, what's the y-coordinate of our vertex? Because our minimum is always equal to the y-coordinate. It's y equals 0. Axis of symmetry. We know the axis of symmetry passes through the center of our quadratic, passes through the vertex. It's always equal, or x equals your x-coordinate. Well, what's the x-coordinate of our vertex? It's 3. So our axis of symmetry is x equals 3. Solutions. Once again, 0 solutions, x-intercepts, these all mean the same thing. So our solutions is where do we cross the x-axis? With this function, we actually only cross the x-axis once. There's only one location where we touch the x-axis, and that is right at the vertex. I know my graph's not perfect, so it looks like we might kind of touch it twice. But there is only one solution where we cross the x-axis, and that is at 3, 0, which is actually our vertex once again. The domain, once again, is all real numbers. We can keep going to the left. We can keep going to the right, to positive infinity, to negative infinity. It doesn't matter. So all real numbers. Now, the range of our function. So we said we have a minimum of our vertex. So that means if it's a minimum, that's the lowest value we can reach. We can only go above that minimum. So that means y is going to be greater than or equal to, because y needs to be bigger than that minimum. Our minimum was our y-coordinate of 0. Sorry about that. Whoa, that was weird. And then lastly, we have our y-intercept. Now, where do we cross the y-axis? So we actually see that we cross our y-axis right here. I don't know what's my function doing. There we go. All right, we actually see we cross our y-axis right here, which we said was at 2.25. So our y-intercept is going to be 0. 2.25 is the height because we went 2.25 up from 0. And those would be our key features. All right, we're going to look at one last question, and then that's where we'll call it for a day for right now, or on this video at least. All right, the vertex of the parabola, once again, parabola is the same thing as quadratic. It's just two different words to represent the same thing. The vertex of the parabola in the y-x plane is 0, c. Which of the following is true about the parabola with the equation y equals negative a quantity x minus b squared plus c? The vertex is BC and the graph opens upward. The vertex is BC and the graph opens downward. The vertex is negative BC and the graph opens upward, or the vertex is negative BC and the graph opens downward. All right, so looking at this function, we know that our function is negative a quantity x minus b squared plus c. Now, we know what a, b, and c does to our function. We know that a determines how the width and whether it's facing upward or downward. We know that b determines the horizontal change of our vertex, and then our c determines the vertical change of our vertex, because we know that's our negative h squared plus k. Now, if we look, the first thing I notice is I have a negative a here. So because it's a negative a, I know it's a negative number, so my vertex is going to be frowny. So because I'm frowning, I'm going down. So that means our graph is going to open downward. So we already know that it's not going to be this one, and it's not going to be this one, because our function has to open downward. So now we have to determine, is the vertex going to be BC, or is the vertex going to be negative BC? So once again, we know it's always opposite of what shows up, or the b is always going to be opposite of what shows up in the function, because it's minus hk. So we always take the opposite of what shows up in the function, and that's going to be our vertex. So if it's negative b plus c here, that we need to be positive b plus d. So b is going to be our correct solution in this case. All right, that's where we're going to stop it for today. You're going to have a little bit of some practice over vertex form, like looking at the equation, identifying the vertex from that, and then a little bit of practice after that. So let me know if you have any other questions, and that's where we'll end it for right now.